super cool topic. It's called the Rayleigh Criterion. It's one of those things that you know that happen, but you don't know the science behind it. But today we're gonna learn it. So the Rayleigh Criterion says that two images are just resolvable when the center of the diffraction pattern of one is directly over the first minute of the diffraction pattern of the other. And whoa, lots of words, but we're gonna break it down. But let's see. So two images, and then resolvable, and then center, and then diffraction pattern, and then first minimum. And yes, those are the important ones. But the first thing we're going to talk about is diffraction. So you probably know about diffraction, but just to recap, it's the changing of a light ray's direction when it passes through variations in matter. So what? The thing with diffraction is that it limits detail in an image. And what does this mean basically that it limits resolution. So the more diffraction, the more limited the resolution, the less you will see. And one example of this is these three images right here. So A, we're seeing just one source of light, but here we can tell that it's fuzzy. This is the diffraction going on. This is the spreading of light. Um, and one thing we need to know is that this light is passing through a small circular aperture and produces a diffraction pattern. Basically, this fuzziness right here. And the circular aperture can mean, like a mirror or a telescope, your eyes, and yes. Then we look at B, and you can tell there are two light sources here. We have one and two, but here you cannot tell they're apart. They look as if they were sticking together, and this is due to the diffraction right here and the distance they're apart. But now, what if they get closer together? Then we get C. In C, we cannot tell them apart. We have the same diffraction pattern than the other two, but since they're closer, we have no good detail or resolution. So it just looks like one body of light. And another example of this is these eight lines. Um, so we can separate them by letters. So this is A, B, C, and D. And if you walk away from your phone or your laptop or whatever you're using to watch this video, um, you're gonna notice that D becomes one line, but A, it's gonna, you're gonna tell that there are two lines. But this thing right here is gonna become just one, maybe thick line, depending on what you see. And this is because of this distance between these light sources, which increases, um, I mean, the resolution de decreases with how close they're together. So, um, this diffraction-like spreading of light is due to the diameter of the light beam and not the aperture. So this light source, if you look at it with your eyes or using your cameras, still looking at it with your eyes, this diffraction right here, this is spread of light, it's still gonna be there. It's not due to the aperture, it's just nature of light. Can we look better if we adjust the aperture? Yes, but this happens before it gets there. So it's not the aperture's fault. But what? How does all of this how do all of this connect with the Rayleigh criterion? So let's just learn about diffraction patterns. So right here, we have a diffraction pattern, and this basically is the intensity of the light source. So here in the center, we have the central maximum, and here we have the first minimum. The first minimum, it's an angle, and it's equal to 1.22 times lambda over d. And this is the case, this is for every case in a circular aperture. So lambda, it's the wavelength of light. It's the diameter of the aperture, or the lens, or the mirror. And the unit of this angle right here is in radians. Okay, so what's the big deal with this? Well, right here we have a light source, right? Now, this criterion says that if we have the central maximum of the other object directly over the first minimum of the first object, so it would be like right here almost, you would be able to tell them apart. Okay, so this is not a good example. I mean, it is, but let's just try it again. So we have here, and right here, and then here, and right here, and our objects will be right here. Awesome. So yeah, here you would be able to tell them apart based on Rayleigh's criterion, and the reason is he calls this to be resolvable. Basically means that you would have a good resolution, a good detail, because they're not too close. And if we look at it from the definition we had at the beginning, we have two images, 1 and 2, that are just resolvable when the center of the diffraction pattern, so this center right here, of one is directly over the first minimum, this dot right here, of the diffraction pattern of the other. So in order to be able to tell these two apart, this center would have to be directly over the first minimum of the first object. So that's why we had so many problems looking at the example when we have two light sources right here, because they were so close together. And not only that, we had diffraction going on here, and at the end it would become just one source of light. But if they follow the Rayleigh criterion, that wouldn't be the case. So I hope that now you get to understand what the Rayleigh criterion is, that all of these important words like resolvable, or the fraction pattern, and first minimum are not difficult to understand. But yeah, hope you like the video.